So welcome everyone to this webinar about savings in BigQuery, and I hope you all gain some great insights today. And don't hesitate to ask questions in the chat now. We'll try to answer some of them during the presentation, or just ask afterwards. And you can always just DM me or Johan on LinkedIn if you have any other questions. So, who am I? My name is Kalle Ström, and I come from Eskilstuna, Sweden. I've been working almost 2 years now as a digital analyst, and I started out with studying marketing communication and was mainly focusing on the creative side. But then I realized that I really love to deep dive into and solve problems and also see them through from start to finish. So connecting this marketing background with the technical aspect made it perfect to work with what I do today at Control Digital. Here I work mainly with creating technical solutions, working with tracking in GTM, client side, server side, visualizing data, and also doing all the stuff in between. So I work a lot with data in GCP, so a lot of BigQuery, which I'm going to talk about today. So when I started out to work as an analyst and in BigQuery specifically, I used to be very scared all the time, very stressed, very insecure, and also thinking, what if this is going to cost us $1 billion? After a while, I got tired of this and started to deep dive more into how does BigQuery work and what is driving costs. And so now I am still scared, I'm still stressed, but I'm not so insecure, and I'm sure that it's not going to cost $1 billion. And that is what I'm hoping to help you guys with today as well. So today I'm going to be talking about what is BigQuery, what makes it cost money, what can we do to minimize the costs, and show you some examples live in BigQuery. So BigQuery is a serverless enterprise data warehouse that lets you store, query, and analyze large amounts of data. And one important thing about BigQuery is that it separates the storage from the compute. And the storage layer is responsible for ingesting, storing the data, while the compute layer is responsible for running your queries, analytics, and nowadays even machine learning directly inside of BigQuery. And these two layers work independently of each other. In older databases, storage and compute were tightly coupled, and that meant that heavy queries could block other users. Databases could become slow, and teams had to think a lot more about capacity and resource management. While with BigQuery removes most of that operational overhead and lets us focus on analyzing and model data. And BigQuery pricing is like a utility bill, we can call it, like an electricity bill is better. You pay for what you use in kind of a pay-as-you-go service. And the costs generally fall into two main buckets. And the first one is storage. And there we have active storage, and that's data that has been modified in the last 90 days. And that costs around $0.02 per gigabyte per month. And then we have long-term storage, which is data that hasn't been modified in the last 90 days, and that's half the cost of active storage. We also have logical and physical storage, but I'm going to talk more about that later. The second bucket, which is most of the time the more expensive part, and that's analysis or running your queries. And there's two ways to pay for this. It's on-demand pricing, which is the default one when you start up a project in BigQuery, and there you're charged for the charging is based on the amount of data scanned by your queries. So currently that is about $6.25 per terabyte scanned. You also have capacity pricing, where you pay for slots or virtual CPUs per hour. And that is something that usually very large companies are using to have more predictable monthly flat rate. But I'm not talking about that today. I'm talking about the on-demand pricing. We also have a third bucket technically, which is about BigQuery machine learning, data egress, streaming inserts. And these things are usually a little bit more expensive and harder to predict, worth mentioning, but I will not talk about those today either. Before I start to go through the tips, I will mention partitioning and clustering a lot today. And so if And if it's one thing you take away from this presentation, it should be partitioning and clustering. It's not just important how you query your data, it also matters how the data is stored and prepared. And if you query a partitioned or cluster table, you can drastically reduce the amount of data that's processed. So to explain it, if you imagine like a library where all the books are just thrown into a pile, finding a specific book would take forever. Now imagine that they are sorted in alphabetical order or by date when they were released. It would be a lot easier to find it then, and that is partitioning. Clustering would then be to add on a second sorting method, like putting them into different boxes based on country of origin. And now it would be even easier to find the book. So partitioning and clustering can tell BigQuery what we're looking for, and it can find it easier. So now to get to the tips that can hopefully help you save some costs. We can change the way we query directly in BigQuery. And the first one is about limit. And limit does not reduce cost. It only limits the result that comes out of the query and not the number of bytes scanned to create the results. And it is the bytes scanned we are paying for. So if we put limit equals limit 1, we get 1 row in the result, but the amount of bytes scanned will be the same. In some other data warehouses, their limit can reduce bytes scanned, but in BigQuery it doesn't. And don't use select star. This is something that can have a big effect, especially if we're working with huge tables. Usually we only need a couple of columns and not the whole one. And the raw data in GA4, just as an example, has over 100 columns. And I can't think of any situation where I actually need all of them. And BigQuery is a columnar-based database, not row-based, like MySQL. So that is why this can have such a huge effect. And instead of using select star to get like an overview of your table, which people usually do, you have like a preview tab where you can see the columns, rows, and the data. And you also can check out the schema without using select star by looking at the schema tab. Use the where statement. So if the table is partitioned or clustered, the where statement can help you reduce scanned bytes by a lot. Only scanning one date instead of all dates available in a table helps you a lot, and it's a great way to reduce bytes. And this final one for this part is something that helped me a lot when I started to work in BigQuery, and I was scared of making my queries cost too much. You can tell BigQuery to only give you a sample size where you decide the percentage of how big the sample size will be. And it works great when you're just testing queries, debugging, or and want to reduce the costs. It doesn't work well, though, for real analysis, since you get a sample size, and if you run the query again, you will get a different sample. So let's jump into BigQuery so I can show you how this actually has an effect. And we'll start here with the select star example. Up top here, I've copied a public data set called the look ecom events. And now if we just do select star from that table, if we run that and we look down here, we will see that it's estimated to process 367 megabytes if we run this. And like I said, we usually never need all of the columns. So let's just look at traffic source and event type. If we do that, instead of 367, it goes down to 39 megabytes. And in percentages, that's huge. And if everyone in the company would resort to this instead of select star, that has a huge effect in the long run. Even if we run this query, maybe we can't analyze it that much. If we run this one at the bottom, where we do traffic source, event type, and count how many events happen per traffic source, which is maybe more like an actual analysis. So we have only added the count and group by. It's still 39 megabytes, and just to show that it's still way less than the select star. And then we have the where statement. that if we use that on a partitioned or clustered column, it can help us reduce the bytes a lot. I have created two tables. They have exactly the same amount of data and the exact same data. However, the top one here is partitioned and clustered, and the bottom one here is not. So let's just start with, if you would run this now, select star on everything, it's 367 once again. But if we add in the where statement that we only want to look at 2 months of data, we see that it's reduced to 29 megabytes instead. And even if you run this query, you can see here we have the results. You can go to job information, and now the results were cached. You just have to remove that. That's something that's good to know, that BigQuery can use cached results if you have run this query before. Let's run it again. And here we can see that bytes build is 30 megabytes. So if I then add the clustered columns, which is user ID and event type, to my where statement, we'll see that the estimated will still be the same as we had before. But when I run it, we can see that it went down from 30 bytes build to 28. And that's a difference of 2 megabytes, which is in this case maybe not that much. But if we would work on a huge table and you also need it to work faster, this is a great way to do it, to reduce bytes. And just to finally show you, the query down here is exactly the same, but it's on a table that's not partitioned and clustered. If we would run the exact same query on this table, it's still 367 megabytes, even though I told it to only look at a specific date, specific user ID, and event type. And then the final example for this part. Here we look at the partition and cluster table, and we're looking at 2 months worth of data. And right now, this is 29 megabytes estimated if we run this. If we add limit 10, so we only get 10 rows, we see that it's still around 30 megabytes. It doesn't make a difference to add it. And then we have the table sample system. Maybe this is a query I just want to debug something and make sure that it works, or I get some sort of confirmation that it works. We add a table sample system 10%, and it goes down now from 29 to 2.9, which is 10% of the original amounts of bytes processed. So it's a great way to reduce bytes if you want to be safe. There we go. So on to the next part. It's not only about how we query the data, it's also about storing data, like I talked about before. And a lot of companies like to save data because one day they might need it. Usually the value of data, if not acted on, is removed pretty quickly. And if you keep it all in BigQuery, it can rack up costs, even though it's usually the cheap part. So to fix this, it's good to set up a TTL, a time to live on tables, because sometimes you just keep it, sometimes you even forget to delete the data. And you can create this on a whole data set or just on a table. And if you set a TTL, that way it will automatically delete the data after the time that you have set. So you can either set it on the whole table, so it's automatically deleted after 3 days, or you can set it on a partition like date. So data that is older than 30 days will be deleted from this table. We also have long-term storage, which gets activated automatically after data hasn't been modified for 90 days. And this is one way of saving storage costs. Long-term storage is a 50% discount compared to active storage. So make sure that you partition your tables on date, because if a partition is modified, it will become active storage again. So if we would partition on another integer that might change row that's not supposed to, the long-term storage will break and become active storage again. And then we have physical and logical storage. And this one took me a while to understand how to optimize. Physical storage costs double versus logical storage. However, physical storage is very good at compressing data. So we can make your table smaller in bytes. But you pay for the availability of to time travel and fetch data that's gotten deleted. Logical storage costs more per byte, but you don't have to pay for the time travel data. You only pay for data when it actually exists. However, logical storage doesn't compress the data. So if you have tables that can't be compressed, logical storage might be better. I'll walk you through some calculation example just to make this clearer. So here we have a 10 terabyte table of structured server logs, mostly text and repeating status codes. And this usually compresses really well with a ratio 10:1 usually. So if you would have logical storage on this table, that would be 10,000 gigabytes times 0.02, and that would be $200 a month. Physical storage costs more per byte, but this can compress. Physical storage compresses the table down to 1,000 gigabytes times 0.04, which is $40. So by switching to physical storage instead of logical, we would save $160 a month. Example number 2. Here we have a 1 terabyte staging table that we delete and reload every single day. And the problem here is, even though the table is only 1 terabyte, BigQuery keeps the deleted data for 7 days of time travel plus 7 days of failsafe. So if we had logical storage here, it would be 1,000 gigabytes times 0.02, because we only pay for data when it's actually there, and that's $20. While with physical, we would pay for the current 1,000 gigabytes plus 13,000 gigabytes from the previous versions in retention. So that's a total of 14,000 gigabytes, and that would be $560 per month. So if we would have physical storage here instead of logical, we would pay 28 times more because of the high data share. So it's not only about storing and choosing the correct way, it's also how we set up the tables. And we can actually adapt them to fit our needs to save costs. And if there are multiple queries running each day and people doing analysis in BigQuery, that cost can mount up. If we query huge tables, we make calculations, and we unnest them all the time. It's better to have a raw data table, like with the GA4 data, and then create like a flattened table with the data that you need, and pre-aggregations are done, like on creating a session ID as an example. This query will only then run once a day, and the other queries will be done on this more optimized table where we can write simpler queries and it won't take that many bytes. Partitioning and clustering makes you save a lot of bytes when you query your tables. Like I said before, if you partition a table on the date column, it tells BigQuery to only scan the dates you have given in your query's where statement, and it doesn't care about the rest of the rows. If a table is not partitioned or clustered, it will always have to scan the whole table every time you're querying on it, even if you're using a where statement. So if you would, as an example, connect a table to Looker Studio, and it's a big table where people are doing a lot of analysis, even though they have a date filter, if the table isn't partitioned, we will constantly get queries that scan this whole table, and the cost will be huge. And in connection to this, you can also enforce partitioning on your tables, which means that if someone is going to query your table, you have to use the partition in your where statement. So if we partition on date, they always have to write where date equals something. So then there's no chance of someone accidentally scanning the whole table. And so to show you here, I have created 3 tables. One is just a copy of the raw GA4 data, and it looks as it's supposed to, with event name, and then we have all the nested event parameters and stuff like that. Based on this, I created a flattened one where I have unnested, I have already calculated a session ID that we need and stuff like that. So every event param that we need is a known column. And that would look something like this, where we have, where every row is one event and there is nothing nested. And in the end here, we can see I already calculated session ID and things like that. And based on this, we can take it even further to if a company is doing a lot of session analysis instead of just event-based. So then I created a table where every row is one session, where we have some session data, start timestamp, end duration, how many page views, and so on. And if we then would do analysis, let's say that we want to just count how many sessions have we had during a specific time period or forever. If I would do that calculation on the raw data, which I'm doing at the top here, that would be approximately 40 megabytes if I run this query. If I would do this exactly the same calculation on the flattened event table, we see that that's instead 4 megabytes, which is about 10% of the original amount. But this is session. We're doing session analysis, you could say. So let's do this query instead on the session table that we created. And it goes down from 4 megabytes to 663 kilobytes, which in percentage, I don't even know how much lower that is, but it's a lot. So adapting your tables can make a huge difference. I also created two tables where every row is a purchase and you get purchase amount, country, and event time. And let's say that a company want to do analysis every day on like how much revenue are we getting every day depending on country and date. So instead of doing that on this raw table every time, we create one table with a summary where everything is pre-aggregated. So here we see event date from Brazil, we got 144 purchases, total revenue, average revenue, and so on. And if we would query these tables, so here we have the raw user activity where every row is a purchase. To calculate how much revenue we're getting for each country each day, that would be 2.23 megabytes. If I would do the same analysis on the pre-aggregated table, we go down from 2 megabytes to, I forgot the select statement, from 2 megabytes to 13 kilobytes, which is once again in percentages a huge difference. And finally, we have the enforced partitioning that I was talking about. So here I'm showing you how to set up. We create a new table and we want to partition it on a date column with we have at created at. So we write partition by date created at. We cluster it by event type. And then we can add an option statement. And here we can write require partition filter equals true. And this creates this enforcement that you have to use the partitioning in the where statement. So we can actually just run this quickly. And then we get this new table. We query it. That. So now I'm doing the select star that we're not supposed to do. And right now it's 0 bytes. But now we are able to query this. If I would remove the where statement, this error message cannot query over a table without a filter on the partition column. So it's a great way to have like a safety net. Okay, so and setting up budget alerts. So that's something you can do to make sure that it doesn't get out of hand and you can act before it's too late usually. And it's a very good safety net as well. So it's a pretty common tip to set up budget alerts. So if you get alerted if spending is starting to get too much, and this way you can act before it gets out of hand. And you can set up specific thresholds, like you want to get notified when we're 50% towards the budget or 75%. And something that's good to know is that it can take up to 24 hours for cost data to get into BigQuery or to billing. So it can be already too late when you get the notification. And if someone would run a query that costs $1,000, the query will still run. So it will already have happened. But then you can set up quotas in GCP. If you go into APIs and go to the BigQuery API, you can set up quotas per project or even as granular as per user. So you can limit how much people are available to query. So every single user can only query 1 terabyte per day or something like that. And if someone would then try to query above that, the query will stop and you won't be incurred any costs at all. So if you have a lot of people in BigQuery doing different things, you can try to label things as well. So you can also keep track of what belongs to which team, and you know which team is possibly making you spend thousands of dollars. And the last one here, but not least, set up a dashboard where you can see what is being queried during the day, what tables are we working on, how big was the jobs. And this is a great way to monitor what your BigQuery budget is actually going to. And to show you here, we start at the bottom now. So there's something you can query that's called information schema.jobs. And this is a great resource to use to monitor the costs that you have. And if you query this, we can see that we have, you get who did it, user email, job ID, job type. You can even see the query that was done, and you can see total bytes processed and calculate costs based on that. And up here, I'm not going to walk through this whole query, but here is an example query that you can use to set up a dashboard. So this one is specifically created for like Looker Studio and Dataform and other stuff as well. So we can see how much we are spending on tables that are connected to Looker Studio or Dataform. And that would look something like this, where we can see how much gigabyte is being spent every day, or how much we're paying for, who is doing these queries, and what table has been referenced. You can add the table ID and then also connect it maybe to a table with the names of the Looker Studio dashboards. But this is just like a basic setup that works really well. So what should you take with you from all of this that I've been walking through? Think before you query. What do you actually need, and how can we minimize bytes scanned? Storage is usually the smallest cost, but it can build up over time. Budget alerts help you keep track and let you act before it goes bad. Learning about costs makes it easier to work and easier to query with confidence. Thanks for listening.
And thank you, Kalle, for learning us all about this. So before we jump into questions, I want to highlight once again, we have a sort of follow-up webinar, May 27. You can find a link in the chat where we'll talk more about BigQuery, working with SQL, focusing on the Google Analytics data. I also want to post in the chat that Kalle wrote an article about this. So we have summarized all these steps and findings, and you can find that article on our site and in the chat now as well. So let's jump to questions. If you have any questions, you can still write them in the chat. We got a few in the Q&A that I want to highlight, and that is, you walked through a lot of steps. that you do. How do you like prioritize? Where should I begin? What is most important, and so on?
To prioritize, I would probably start with in the order that I showed it, kind of. The first one is maybe more focused on what you can do yourself, like how the way you query, and also you can teach others in the company, of course. But I would start to focus on that and make sure that you get it in as a habit, because I still do the select star even though I'm not supposed to. But I'm starting to build a habit where I don't use it, and start to use table sample and stuff like that instead. And then I would start focusing on like the way we do storage, and because the thing is, the query stuff you can do yourself, while how we work as a company, if you are a huge company maybe that works in BigQuery, how we store the data is something that of course you yourself can fix, but everyone needs to be on top of that as well. So I would basically go through these steps that I gave, but start with how you query and then look into like storage and all of those things, because those are things that the whole company should actually work with.
And the next question is on Looker Studio, or now called Data Studio. How does that work with cost, and like what to look out for there? If we create tables in BigQuery and then we connect them to Data Studio or Looker Studio for visualization.
Yeah, there I gave an example. If you connect a table to Looker that's not partitioned, even though you're using a filter in Looker Studio with date, it will still connect to the table, query the whole table, even though you're just looking at 1 week worth of data, and the cost might go up. And one other problem that we have with Data Studio can be that we're not really in control of the query that is sent over to GCP every time. So it's good to know how it works, but specifically optimize the tables if you know that it's going to be used in Looker, because we don't know if we let a lot of people into that dashboard. We don't know what they're going to do, what filters they're going to use, and how it works. So that is something to keep in mind when you create a table specifically to use in Looker Studio, to make sure that, once again, partitioned, clustered, and make sure that it's optimized as much as possible.
And the last one on my list, you talk about creating aggregated tables based on the raw data, and then use those aggregated tables for your analysis. If you work with, for example, the Google Analytics raw data, what would your approach be to that? What sort of tables would you create?
I think it's like the ones I showed you now, with you have the raw data, you have the event, you have another event table, but that's flattened, and you have already done calculations on session ID and things like that. And once again, the session table. You can, of course, also create like a user table. If you do a lot of user scoping, you can do one that's based on item scope. I think there are a lot of possibilities that you can do, especially if you work through like Dataform and set this up. It makes it a lot easier. But I think that's a good basic start, especially if you also want to learn. And people are usually using those tables, basic events, and a lot of people are still using only sessions tables, I've noticed. So to set up a session table, I think it's a very good start.
And I want to add in that there as well, because now we're talking query cost, but there is also a time cost for you as an analyst. How much time you can save if you're working with prepared tables and don't have to access and work with the raw data in every query, every dashboard you build. So that's as well. Great, thank you. And as you can see on the screen, if you have any more questions, you can connect with Kalle on LinkedIn. He's writing a lot of great stuff on this topic, or reach out to him on email if you have any more questions. Otherwise, thank you for this morning, and we hope to see you all on May the 27th, where we'll continue the discussion.